Hi, I am Dr. Eli Kolberg from Unlimited Robotics, and in this video I will talk about green energy. Green energy is a subgroup of renewable energy. It represents the energy sources and renewable energy sources that yield the most benefit to the environment. It includes electricity that is produced from wind, sun, geothermic heat, gas which is produced as a result of operation of bacteria on an organic garbage, biomass, which is the overall amount of organisms that live in a given area and are harmless, and the small hydroelectric stations with little damage. Green energy sources has no emission. They decrease the use of coal and the carbon emission. Green energy is also renewable that renews itself in a short period of time. Green energy is not perishable. Next figure presents a comparison among various energy types. The standard energy source, like coal, nuclear energy, oil, or natural gas, which are less efficient. Renewable energy, like big hydroelectric station, urban solid garbage, which are more efficient. And green energy, which is also renewable, can use wind, solar, the sun, biomass, geothermic, biologic gas, small hydroelectric station with little damage, which are most efficient. As an example of green energy, we will look at the wind turbine. A wind turbine is a machine that uses the wind energy to rotate blades that in turn rotate a generator axis, which produce electricity in its other end. The huge turbine blades resemble the shape of airplane wing since they are built in an efficient aerodynamic way. When wind blows on the turbine blade surface, it causes them to rotate. It is similar to the wind that blows on an airplane's wing, and by that creates a lift force that pushes the wing up. The wing loses kinetic movement energy that is converted into rotation energy of the turbine blades. The amount of energy produced by the turbine is relative to the thrust area of the turbine blades. It means that the longer the turbine blades are, the more energy the turbine will produce. In addition, the faster the wind speed will be, the more energy the turbine will produce. The wind energy is relative to the speed by the power of 3. It means that if the wind will blow in at twice as much speed, the wind energy will increase by 8, which is 2 to the power of 3. The wind changes during time. As a consequence, the electricity produced by a single turbine changes as well. Connecting large amount of turbines together in a specific area and connecting many regions from various areas to a single network will allow for more stable electricity production. The turbine blades are significant, but they are not the only ones. Additional important part is the transmission unit, which converts slow rotation of the blades into high-speed rotation, such that the output axle of the transmission unit will rotate fast enough in order to operate an electric generator. The generator is an important component in a turbine and can be thought of as a huge version of a bicycle dynamo. When the dynamo is attached to the bicycle wheel, it rotates and produces enough energy to have a light from a flashlight. It is similar with a wind turbine, just that in the turbine the generator is operated by the rotating blades and not by the bicycle wheel. The light of the flashlight, in this case, is the lamp that lights at home, which is located many miles from the turbine location. In reality, wind turbines use various types of generators that are not similar to the bicycle dynamo. Next figure presents the structure of wind turbine. We can see the wind blows from the left, the blades that rotates, and there's a transmission gear attached to a generator, that produce electricity that goes to homes through transformer. Next table presents the operating process of the wind turbine while referring to the numbers in the figure. 1. The wind or moving air with kinetic energy flows in the direction of the turbine blades. 2. The blades receive the wind energy. 3. The blades rotate and capture part of kinetic energy of the wind and then rotate the central axle that supports them. Although the blades tips rotate in high speed, the central axle that they are attached to rotates pretty slowly. 4. In most of the modern big turbines, it is possible to control the blade's rotation angle such that they will face the wind with the most efficient angle. It can be done by an electrical motor or by hydraulic equipment. 5. In the turbine, there is a small structure, metal structure, that is placed in upper end of the turbine tower behind the blades. In the metal structure, the transmission gear is located. It is used for converting a slow speed of the central axle into fast enough speed of the generator axle, such that the generator will work efficiently. 6. The generator is located just behind the transmission metal gear structure. The generator converts the kinetic energy received from its rotating axle into an electric energy. Wind speed and direction gauge, weather vane, is located in the rear part of the metal box and supply measurements of the wind speed and direction. 8. Using these measurements allow for rotating all the top parts of the turbine, the blades and metal box, by a motor that allows yawing the top part. The motor is located between the metal box and the tower and is operating such that the top part will face the wind directly and will capture the maximum available energy. If the wind is too strong or strong turbulence arrive, the motor stops working for safety reasons. 9. The electric current that was produced by the generator flows through cables in the turbine tower. 10. A step-up transformer converts the output voltage to voltage that approximately is 50 times as high, such that it will be possible to efficiently transfer it to the network. 11. The electricity reaches the houses that enjoy green energy. The turbine did not produce or consumes gas, emit and contaminate materials or fuel while working. 12. The wind flows after crossing the turbine, but with smaller energy and smaller speed, and with more turbulence that was created during the process. 13. Earth ground in which the cables are connected. Thank you for being with me in this video. Hope to see you in the next one. Bye bye.